Now, before we get started, are there any questions on the homework assignments?
25 and 30.
From which section?
You want me to get the thing out? I wrote all over it. Don't look at that, but you know. Oh, wait. That one has to be.
Label the vertex and axis of symmetry. Now, since this is written in standard form, our vertex is the negative b over 2a, comma, f of negative b over 2a. And this is being related back to our ax squared plus bx plus c. And as we look at this equation here, the value of a is negative 1. The number in front of x squared is our a, and it is negative 1. Is there an x term? No, so that means the value of b is 0. Because really we're saying we have 0x, because it's not there. If it is there, it's 1 or negative 1, depending on the sign. If it's not there, it is 0. Well, we can calculate this out. Negative 0 is just 0. 2 times negative 1 is negative 2. And 0 divided by negative 2 is 0. Which means the x value of the vertex is 0, and our axis of symmetry is x equals 0. Now the next thing we need to do is plug the 0 back into the function. So we'd have negative 0 squared minus 1. Well, 0 squared is still 0, and negative 0 is still 0, and 0 minus 1 gives us negative 1. And that's it. Any other questions on the homework?
Huh?
Any questions on this here? We're good with the homework. Yes?
Oh, 23.
So you're 23. So again, so it's still in standard form, so we're looking at negative b over 2a first. Now the value of b in this case is 8. Value of a is negative 4. We could plug this into the calculator and get an answer, but if we do it by hand, 2 times negative 4 is negative 8. And negative 8 divided by negative 8 is 1. So the x value of the vertex is 1. The axis of symmetry is x is equal to 1. Now at this point here, we can plug this back into the equation to find the y value of the vertex. And if we simplify this down, 1 squared is 1. 8 times 1 is 8, plus 2. Well, negative 4 times 1 is negative 4. 8 plus 2 is 10. And negative 4 plus 10 is 6.
On that one, I got 60, negative 894.
Because I think you multiplied instead of, or, so you did the multiplication then added instead of dividing. Because negative 8 minus 8 would give us 16. Yeah. Now, what we're looking at today are two more forms of quadratic equations. One of them, the first one, is y equals 1 over 4p, parentheses, x minus h squared plus k. Now, for this here, the vertex is the point h comma k. The axis of symmetry is the equation x is equal to h. Now, the new piece of information for this here, one of them is the focus. And our focus for this here, as we see on the board, is h comma k plus p. And the other new part is the directrix, which is the equation y is equal to k minus p. So those two pieces of information are new. We're adding those with these equations here. Now we also have x is equal to 1 over 4p times y minus h squared, or k squared, plus h. And the vertex for this other form is still the point h comma k. Our axis of symmetry changes to y is equal to k. Now the focus for this one here is a little bit different than our y equals, because the focus for this here is going to be h plus p comma k, and our directrix is the equation x is equal to h minus p.
So how will we know? How? Oh, never mind. I got it. Are we gonna get a graph shown like that on everybody's?
Not every one, but we will get information enough to be able to determine it. Because with a graph, y equals is going to be our up or down. And x equals going to be the left or right. Because x equals our equation is going to open to the left or to the right. If it's y equals, it's going to open up or down. It's going to be one or the other. Now the vertex, I'm going to add this here just so we can reference both of them at the same time. But the vertex is written up at the top, h comma k. And if we look at this here,
It's open.
now let's focus back in. With y equals, the h value of the vertex and the focus are both h. So h is the same with this here. Now, if we look at the vertex, for either one, the value is k. But on y equals, the y value of the focus is k plus p. That means from the vertex to the focus, if the y value changes, that means we're dealing with equation where it is y equals. We're dealing with this form because that y value changed. Now, just because it says plus p doesn't mean we're just going to be increasing in a positive direction. Because the value of p could be positive or negative. So it could go in either direction, but if that going from the y value, from the vertex to the focus changes, it means we're using the equation y equals.
So that focuses on the vertex, right?
So the one in the middle, here's vertex. Now if we're given a vertex, and here the x value is h, in the other equation, the x value of the focus is h plus p. So if the focus's x value changes from the vertex to the focus, we're looking at x equals. It's a way to determine which one we use. Now the k values for this here are the same. It's a piece of information that we can look at. Now the directrix telling the two apart is kind of a little bit easier because one is y equals, the other is x equals. They're a little bit more distinct. The axis of symmetry is the same way. Y equals, x equals. But let's look at this first one here. Write an equation of the graph shown. Now, as we look at this one here, we need to determine which equation we're going to be using first, because we've got to determine that first before we can do anything else. Now, since we're given a graph, which way does it open? Up and down, or left or right?
Or to the right.
It's opening to the right. And which one of the two equations open left or right? X equals or y equals? X equals. So we can start off with x is equal to 1 over 4p times y minus k squared plus h. So again, how did we know this equation? That this is the one we needed?
Or it opens to the right.
It opens to the left-right. So just because of how it was set up, we were able to pick the correct one. And again, referring back to these general forms is what's going to be key for this here. Referring back to these here, and just like the previous sections, I'm not expecting you to memorize this, but I do expect you to become familiar with how they work together, how it connects, what goes where. And even looking at this equation, the x and y are going to stay put. When we get the equation, x is going to be still on the side by itself, y is still going to be inside the parentheses. But we need to find the values of what? H, k, and p. Because I need the values for h, k, and p. X and y are still going to be there at the end. And that's what we're going to get to. We're going to get to that there. Now, looking at the graph, they did give us two pieces of information. One of them is the vertex, and the other is the focus. Now, the vertex for us here, its coordinate values, well, the x value is what? Not quite, because we went 2 spots and got 2. So the next spot is going to be because it's going by 2s, and the y value is going to be 2 because we went up 1, but it's again going by 2s. So the vertex is the point 6, 2. Now what's our coordinates for the focus? 10, and the y value is 10, 2. So we got the vertex and the focus. Now if we look at the general forms of both of these here, the vertex in general form was the point h, comma, k. Because the general form for the vertex is h, comma, k. because that's just from our equations. And the focus was h plus p comma k. Now I got that purely from, so if I look at x equals, the focus is, well, apparently it's in a scroll, h plus p comma k. Again, we're matching these up. What do we have and what does it match up to the general form? And that's going to be key, especially when solving these here, finding the equation or going the other way around. Now looking at this here, just with the vertex, well, the vertex tells me the value of h. The value of h is what? 6. What is the value of k? 2. Now for the focus, the y value k does match. It's still 2. But the x value of the focus, the 10, is being represented by what? H plus p. H plus p is 10. So this is also telling me that h plus p is equal to 10. So we don't know what the value p is, correct? But do we know what h is? So we're saying 6 plus p is, so we subtract both sides, telling us p is,
Oh, hold on.
Wait, so that's how we do it?
so that's what we're, yeah. But again, the reason that we're able to do that and say that is because what did we do? We lined up the vertex with the general equation, or h plus k. We lined up the focus with its general equation, h plus p comma k. We're lining it up and matching up what goes with what, and then filling in what we know. Because with the vertex, it gave us that h is 6, k is 2. We lined that up. We see over here, k is still 2, which should match up. And then we saw that h plus p was 10. The vertex immediately gave us h and k. Our x value of the vertex, h plus p equals 10. We could set that up. We filled in our h value and found p. Because we're not doing anything more than just lining up what we know the general equation is with the information given. Now to find the equation, we plug in the information we have. Because we have x is equal to 1 over 4p. Well, the value of p is 4. Parentheses, y minus k. Well, the value of k is, and h is. Now, at this point, we do need to simplify. Because we can't leave this as 1 over 4 times 4. Well, 4 times 4 is? Now, there is less to it than what we're going through, but I am really trying to drive home these points of how this is lining up.
So we can skip. We can skip that KP equal thing.
You can. I would still list them out, especially as you're getting used to this. Because again, as I said at the beginning of the year, Algebra 2 has that notation that it's the hardest math class that you're going to take. And it's not because in and of itself it's difficult. Because doing this here is new. You've never done this in Algebra 1 geometry anywhere up to this point. That's why some of these are hard, because it is so new. But again, with these problems that we're doing today and tomorrow, we're lining them up. If you line them up with the general form of what everything matches up with, what we did here and here, it makes these easier to work with. Yes?
I don't need these ties.
Yes.
When would you and what like your
Uh,
when would you set that?
so we're looking at kind of a two-dimensional version of this, but there are parabolas used in most places. A dish. There's a satellite dish where you get DirecTV or trying to communicate with a satellite. The focus is where the antenna, the receiver, goes to get. So if you're actually building a satellite, the focus is where this is at. Now, I'm going to erase this here so I can show this. Now, what's interesting is that the distance from here to here is actually the same distance from there to
It's just
there.
because I in my brain can process anything that you use that at all.
Now, what's also kind of interesting is these two distances here and here are actually the same. So those other two red lines, the distance from that point on the parabola to that focus are actually the same.
What are they doing in there?
Working on the fire suppression system. Because the distance to get to that focus point from any two similar points on the quadratic or on this parabola are actually the same. So if you're especially with that receiver being at its location helps that no matter where it hits, it will get to that point. That's why satellite dishes work the way they do. But beyond that, no, you're not going to use this. You know, but those are parabolas. Those are quadratics. But they're in a three-dimensional form instead of a two-dimensional form.
I was just like I've been thinking about this whole time.
Yeah. And the distance from a point on the parabola to the directrix are the exact same, actually.
So you're telling me that dish people like
Most of it is calculated already before they even get there. The dish, if you were to build a dish, you would need to know these calculations. No, but most of them, the calculator can do it for them. Now, let's look at this next one here. Which direction is it opening?
right.
It's opening to the left and right, which means our equation that we're using for this here is 1 over 4p times y minus k squared plus h. And again, knowing which direction it opens or being able to identify the information given will help us figure out our starting point, which equation we're looking at. Now, they gave us the vertex in focus also. Well, the vertex for this is -2 and 4. The focus is 2 and 4. Now, looking at this one here, if we just had the vertex in focus, does the x or y value change from the vertex to the focus? Which one changes, the x or y? The x value changes from the vertex to the focus. The y value stays the same. Now, if we look back at the general forms, so vertex, if I looked at the y equals, here, vertex is h, focus is h. Those are the same, yes? So could it be y equals?
Yeah.
Well, are our x value of the vertex and focus the same for this problem?
But the white is
No, but the y is, yes? Here, for y equals, the y value of the focus is k plus p, and the vertex is just k. Those don't line up. Those don't match, correct? Because for it to go with y equals, the x values have to be the same, and they're not. Let's look at the other equation. from vertex to focus here, the x value goes from h to h plus p. Those are changing, yes? And the other one, the k value, from here to here is going from k to k. The y value stayed the same, yes? Because of that, we can say that it is our x equals, because it's opening left or right. Those values will also tell us which one it is. Questions on that there? Because again, we're looking at what is changing. So if I looked at this here, the x value is changing. It's not so much that it's going from negative to positive or positive negative. It's the fact that it is not the same. But the y value is staying the same. It's 4 and 4. And in the two general forms, here, for x equals, the x value of the focus is changing from the vertex because we're adding a value to it. For the other one, the y value is changing.
There's just so much going on.
I got what you're saying.
Because
I get it. I get most of it. There's a lot going on, so I feel like it's just easier to do the problem instead of like
right.
trying to think about all that in my head.
But so again, what I really want to drive home, and the reason that we're going at this kind of pace for this, is because I want you guys to see this. In that the vertex, here it's h, here it's h plus p. We're adding a value to it. We're changing the value. Yes? Because what we're seeing in the point is the simplified version. So for h plus p, whatever that value of p is has already been added for the focus. And so whatever h and h plus p is, these two are going to have different values. But the k values are going to be the, here we can see that the h value changed. But the y value is the same. Because the x value changed from the vertex to the focus, it means our equation is this here.
I get it.
That's,
Putting that in picture,
yeah.
I was confused on why we were using vertex, but then the paper. Vertex focus together.
Yes. Now, if they give us the vertex and the y value changes,
See, I don't know how to put it. I don't even know how to say it, but I get it.
right, then we're looking at this. So again, we'll be looking at this because it's not always going to give us the graph. So we have to see how is it changing from one to the other. Now they did give us the graph for this. And again, just like the last one, we need to know the values of h, k, and now the vertex is still h comma k. For the focus, because again, we know that we're dealing with x equals, so we go to those general forms and grab our pieces of information. Now the vertex, and some of the times that's what it is, it's just getting that last little piece, and it takes it from confusing to understanding.
It looks like a bunch of letters and numbers before that, and I didn't really.
And again, it's matching it up. It's matching up what we have to the general forms. Because the vertex h is -2. The vertex tells us h is -2. The k value in this case is what? 4. And if we look it over at the focus, it does agree. K is indeed 4.
So we're using vertex.
H and K.
Vertex.
Yeah, so the vertex is the point on the parabola that's going to be the maximum or minimum. Here we're talking about a maximum, minimum, left to right. Now, we don't have P, the value P directly, but we know that H plus P is, so we have to solve for the value of P. Now, what is the value of H? So we're saying -2 plus P is, what do we need to do to solve for P? We're going to add 2 to both sides. is negative 2 plus 2 is 0, and 2 plus 2 is 4. Because again, we took what they gave us, vertex and focus, and compared it to the general form and solved from there. Because again, it's matching it up to the general form and then plugging in what we have. So 1 over 4p. Well, what is the value of p in this case? 4. Now the value of k in our case is plus h is. Now we could leave it as plus negative 2. We could have written it in as minus 2. Either one works. Now we do need to simplify our 1 over 4 times 4. So it's 1 over 16. Now the y minus 4 inside the parentheses stays the same. But outside we have negative 2. But again, I really want to drive home the point that we're really just matching it up with the general form. Because if you can match it up with the general form, it flows very smoothly. Questions on this here? Now, we didn't do this with the last one. I want to do it with this one here. Now, I didn't ask for the axis of symmetry, so you don't have to write this. But the axis of symmetry for this one in the general form is y is equal to k. And for us, the value of k is 4. So y is equal to 4. Now the other part was the directrix. And this is x is equal to h minus p. Well, h in this case is negative 2. And p in our case is 6. So negative 2 minus 6 is negative 8. So somewhere over here, the directrix would be, and the axis of symmetry would be going this way here. Now the axis of symmetry cut the graph in half, cut the parabola in half. But because the parabola is opening to the left or right, we can't have x equals for the axis of symmetry anymore. It's got to be y equals. It has to go the other way. Questions on this here so far? The axis of symmetry and the directrix? Yes, we will get to those. But again, if we look at the axis of symmetry or directrix, the directrix in both of them, k and p, h and p, because again, if we find h, k, and p, we can find these two. So they're just the given values. Now they gave us the vertex, which is 1, 0, and the focus is 1, 0.25. Now, which way is this parabola opening? Up and down or left and right? Up. So our equation would be x equals, so y equals 1 over 4p parentheses x minus h squared plus k. Because we know it opens up and down, we can refer to the equation that we have. And again, just like with the previous ones, we need to find the value of h, k, and p. Because if we find these three values, we can plug it back in and find the equation. Now our vertex is still the point h, comma, k. In the general form, vertex is still h, comma, k. Now for this one here, our focus is h, comma, k plus p. Now looking at the vertex form, vertex point, we get our h value, which is, it also tells us our k value, which is, so we know what the value of h is and the value of k, just from the vertex. It told us it was 1, 0. And the focus,
Yeah, how about that?
now, now the only other value we need to find is what? P. Now, we weren't directly told what it is, but we know that k plus p is 0.25. Because our focus for this one here is h comma k plus p. Because for our y equals, the focus is h comma k plus p. When it's x equals, the focus is h plus p comma k. We have a different setup depending on which equation we're looking at. Because the focus is going to be in line with the vertex, and it's going to be inside. So if we're going up and down, the focus is either going to move up if it's opening up, or down if it's moving down. But that's not really the important part. But again, it's referring back to the general form. Since we have y equals, we go and grab the focus from that equation, our h comma k plus p, to get that equation. Questions on this here? What is the value of k? Because 0 plus p is the same as just p, so p is 0.25. Questions on how we found hk or p? 0.25, 0.25 are the same thing. Now, the last thing we need to do, you're good. Now, the last thing we need to do is plug it in. So here we're going to have 1 over 4 times 0.25 times x minus 1 squared plus 0. We plugged in the values of h, k, and p. Now at this point here, we can plug the 1 over 4 times 0.25 in the calculator. As we see here, it's already plugged in. The value is 1. We still have the x minus 1 squared, but the plus 0 is not needed. And realistically, we don't need the times 1 because it's understood. So really, this equation here is just y equals x minus 1 squared. Now again, with any of this here, the reason this works the way it does is because, again, we're going back to the general forms every single time. We're looking at the information given, determining which equation it works with, and then setting up it with the general forms. We're referring it back to the general forms every single time when we plug information in or see where we're getting the numbers from. That's why it's working the way it is and working as nicely as it does. So again, on the homework for this year and the test when we do these here, make sure to keep referring back to these here.